Hello, Luke. Welcome to lesson 23. So, today we're going to be talking about equations primarily, and we're going to be hitting some very important subjects today. So, this is going to be an important lesson. To begin with, though, let's get a couple of definitions out of the way. So, the first topic here is going to be equivalent equations. This guy right here, equivalent equations, and what they are. So let's talk about some equations here. If I have something that looks like this, 3 plus x equals, I don't know, let's make it 12. All right. And then over here, I have, let's say, 5 plus x is equal to 14. Okay, so I have two equations. We'll label these, just for the fun of it, equation 1 and equation 2. Okay, and if we look at these two equations, we might notice that the solution to this equation is actually a 9, right? So what would x have to be in order for 3 plus x to equal 12? Well, if you think about it hard enough, you'll realize that the solution for this guy is going to be a 9. X has to equal a 9. And I could check that by just plugging the 9 in for the x. I could say 3 plus 9 equals 12. 3 plus 9 is 12. And it is true that 12 does equal 12. So, therefore, it's a true equation, and therefore x equals 9 is a solution to this equation. In fact, it's the only solution. There's nothing else that I could plug in for x here that would equate to a 12 when it's added to a 3. So that is our solution for that equation. Now let's go to the next one. And in this next one, again, if we kind of think about it here a little bit, we'll recognize that x is actually a 9 as well, right? Because if I plug that in, 5 plus 9 equals 14. 5 plus 9 is in fact 14, and of course 14 does equal 14, so this is a true equation. Therefore, x equals 9 is our root, or our solution to the equation, right? And again, in fact, it's the only solution for this equation. Now, the thing that we need to notice here is that both equations have the same solution, and that both equations have only that solution. So you might say, all of the solutions for this first equation, equation number 1, all the solutions for this equation are also solutions for this equation, equation number 2, right? Let me say that again. All the solutions for this equation are the solutions for this equation. And I could say that in reverse, too. All the solutions for this equation, equation number 2, are solutions for equation number 1. And that is what we call equivalent equations. These are equivalent equations. And that should kind of make sense. You can almost see the word equal in equivalent. Equivalent means equal, right? So if they're equivalent, it means that they're equal in some way, right? And they're equal because all the solutions in one are also solutions for the other. Okay, so again, that's just getting this terminology out of the way. When we talk about equivalent equations, that's what we're talking about. The solutions for one are the solutions for the other. All right, so hopefully that kind of makes sense to you. What I'd like to do next here is we're just going to start practicing this, how to make equivalent equations. Okay, so if I take an equation such as, well, let's just take this 3 plus x equals 12 again. That's a fine equation. And let's say I want to find another equivalent equation. So we already know that number 2 here is an equivalent equation to number 1. But could we, find another one that's an equivalent equation? Well, the answer is yes. I could find infinitely many equivalent equations here. And the way to do this is by using what's called the additive property of equality. All right, I know it's just a mouthful, it's fancy, but all that really means is that if I take any equation and I add something or subtract something or multiply or divide, we'll be learning that later, but if I do anything to one side of the equation and I also do it to the other side of the equation, I will get an equivalent equation. So in this particular case, let's take that 3 plus x, and we're going to do something to that left side. Let's just add a 3 to it. And actually, maybe just so I make this a little bit more clear, we'll do that part, the original part, in black. So I had 3 plus x, and now I'm going to add a 3 to it. All right, and then I've got the rest of my equation. Now, the important thing to remember here is that in order to create an equivalent equation, what we do to one side, we must do to the other side as well. If you don't, the mathematics police will come and get you and throw you into prison. That's just the rule. You cannot break it. It has to be applied every single time. So if you do something to one side, you must do it to the other side. All right, so bearing that in mind, let's continue this. So now that we've done something to two sides, let's just simplify this side, because there are like terms here that we can work with. So we have a 3 plus a 3. Well, that's actually a 6. So we have a 6, and then we still have our plus x. And then over here we have 12 plus 3. Well, that's 15, right? Now, if you think about this, what would x have to be in order for 6 plus x to equal 15? Hopefully, you recognize that it has to be, in fact, a 9 again. And in fact, that's the only solution that'll work for this equation. So what did we just do? We just created an equivalent equation. We're going to call this one equivalent equation number 3 right here. There it is. It's another equivalent equation. It looks different than these first two, but it in fact has the same solution as the first two, and it's the only solution that will work. And again, how did we do this? That's the important thing to note. We did this by manipulating one side, or actually both sides of the equation, by adding a positive 3 to both sides. All right, so important. Hopefully you see that. So let's just go and do one more. Hey, why not? Let's find another equivalent equation for this 3 plus x equals 12. Well, this time, let's take this 3 plus x and, I don't know, let's add a 10 to it. All right? We're going to add a 10. And actually, I'll do that in a different color again, just so it's clear. We have the original equation, and we're adding a 10 to it. All right? And, of course, that would mean on the other side that we have to add a 10 as well, right? Remember that. Don't forget. Serious offense if you forget that, all right? So once we have that in place, we can now find our like terms and add them up. So we have an x plus a 3 plus a 10, which is going to be a plus 13, which is equal to 12 plus 10, which is a 22. Maybe not quite as obvious, but if you notice, what's the solution? Well, x has to equal 9 again. 9 plus 13 is what will give you 22. So again, we have created another equivalent equation. We'll call this equation number 4. And we could keep doing this. We could just keep going on and on and on. We can do whatever we want from to both sides and get an equivalent equation. For variety here, let's do one where we subtract something. So we have our original equation, the 3 plus x equals 12. We're still using that one. So this time, let's subtract. So we have 3 plus x. Now, let's just subtract a 2. All right? And then we will continue and have our equal and 12. Now we have to subtract 2 again, right? Which color did I use? I think it was this one. Minus 2. So we have 3 plus x minus 2. So 3 minus 2, well, that's a 1. So that leaves us with an x plus 1 equals 12 minus 2, which is a 10. And once again, if you kind of think about that, you'll recognize that x has to equal 9. 9 plus 1 is 10. So you can see where we've added things to both sides, we've subtracted things to both sides, and lo and behold, we still get the same solution. All right? And the reason that's possible is through this additive property of equality. And again, just to put that in simple language, all that means is that you can take an equation and do something to both sides, as long as it's the same thing to both sides, and still get an equivalent equation out of it. All right? And because it's actually the additive, in this case, I should probably say we're adding something to both sides, or adding a negative number, which is like subtracting. All right? So hopefully that makes sense. Now, how are we going to use this? Well, that's the next step here. So let's take another equation. And let's say we have x plus 22 is equal to 36. All right. So it's a very simple equation still. But now we're going to use that rule of adding things to both sides to find an equivalent equation. And the equivalent equation that we want to end up with is an equation that only has x by itself on one side. All right, that's kind of the goal when we solve for any equation in the future, is to try to get that unknown variable all by itself on one side. So we already learned how to manipulate this equation to get different numbers and yet still have the same solution. So let's just use our heads now and think about what we could add to both sides so that we can get x all by itself. And if you think about that long enough, you might recognize that, hey, if I add a negative 22 to this side, all right, which of course means I then need to add a negative 22 over here, all right? But if I add a negative 22 on this side, a beautiful thing happens. The positive 22 and the negative 22, they cancel each other out, and we're left with 0 for those, and all we have left on that side is the x, which is what we're trying to accomplish here. On the other side, we have to take the 36 minus the 22, which is going to give us what? 14. So we have x is equal to 14. That is our equivalent equation that we've just created. Just like we created those other equations, we've just created this equivalent equation. But the beauty of this one is that x is all by itself, thereby revealing what x is. X is a 14. So it's also giving us the root to the equation. All right? So hopefully that makes sense on what we're trying to do here. All we're doing is creating equivalent equations by using our heads and adding or subtracting from both sides a specific number that will give us x all by itself. All right, and because of what we learned earlier, we know that this equivalent equation will have the same solutions as the original equation because of that additive rule of equality. Okay. All right, so hopefully you're following along here. Let's try another one here. And just to make things a little bit more complicated, I know they're going to be doing this in the book as well. They're going to be giving you fractions. So let's try one with some fractions here. So if I have k plus 2 1/3 equals 2/9, and I tell you to solve for k, meaning try to find the solution that would make this equation true for k. All right. So again, we're going to create an equivalent equation here. And how are we going to do that? By using that golden rule, which is that we can add anything to one side so long as we do it to the other side. And in this case, it makes sense to add a negative 2 1/3. I would also add a negative 2 1/3 on this side. And notice how I'm kind of setting this up. There are multiple ways that you can kind of do this on your paper when you solve these problems. This is probably, in my opinion, one of the better ways. It doesn't work quite so well for fractions, but like in the previous problem, this I think is a good way and something that I think you should try to get used to. So I think I want you to do it this way on your homework sheets, where you just subtracting whatever it is or adding whatever it is to one side of the equation and doing it to the other side, and you're just writing it right below the numbers. Okay, so it's all just kind of lined up, and it's pretty clear as to what you're adding or subtracting from both sides. All right, so set it up just like this on your seat work pages. So coming to this point, though, we recognize that positive 2 1/3 and negative 2 1/3, they're going to cross out. They're going to get a 0, and that's going to leave you with a k, which is just what we want. We'll line our equal signs up here. Now here, when you have fractions, it's actually better to set them up maybe on a piece of scratch paper over here somewhere where you can actually work them out. So 2/9 minus 2 1/3. Okay, set it up like that horizontally here across the page. It's a little bit easier. To solve this, you may recall the easiest way to do it is to take your 2/9 minus, take this 2 1/3 and turn it into an improper fraction. Right now it's a mixed number. Let's turn it into an improper fraction. And you remember how to do that, hopefully. 2 times 3 is 6, plus 1 is 7. So we end up with 7/3, right? Now, in order to subtract, we need to have a common denominator. So what will be our common denominator here between the 3 and the 9? Well, it's going to be the 9, right? Be our least common multiple here. So we have our 9. And then 9 times what is 9? Well, it's 1, so this 2 doesn't change. We have our minus sign. 3 times 3 was 9, so we have to take the 7 and multiply it by 3, and that'll give us a 21, right? Hopefully you're following me here. Then we can now add the numerators. So we have a positive 2 and a negative 21, which is going to give us a negative 19/9. All right. So these two combined will give us a negative 19/9. And that is, in fact, our root, our solution for the equation. K equals negative 19/9. Now, it's not a bad idea to check it. Now, fractions are never fun to work with, but they're just messy numbers. Let's just go ahead and give it a try. So to check this, we're going to take that negative 19/9 and we're going to plug it into the K, right? Or in for the K. So instead of a K, we have a negative 19/9, and then we have our plus 2 1/3 equals 2/9. And again, fractions are just messy numbers. They're easier to set up the other way. So we'll set this up over here as, well, I mean, we could do it like this actually. Looking at this, let's do exactly what we did over here. We're gonna find our improper fraction here. So we have a negative 19/9. Our improper fraction is 7/3. It's a positive 7/3 equals our 2/9 over here. Now we have to find our common denominator, which is a 9, again, in this case. So we have, this one doesn't change. We have a negative 19/9. Over here we did 3 times 3, so 7 times 3 is 21. So we have a negative 19, positive 21 over a 9. That's going to give us a positive 2/9. And this is still here. I'm just bringing those down. And we have our equal sign. And if we notice, 2/9 is equal to 2/9. Yay, it checked out. It is a true equation, which means this is a solution, a root to the equation. All right. So hopefully that kind of makes sense. Let's try another one here. Let's try, maybe we'll do one more that's not a fraction. We'll just make one up. Let's go with, and just for the fun of it, let's do a W. A W plus 32 is equal to a 98. Just use some bigger numbers here. So once again, what are we going to do? Well, remembering that golden rule, we can, whatever we do to one side, we do to the other, and it's not going to change the solution. Let's do something. Well, we're trying to get w by itself, so the obvious thing would be to subtract a 32 from both sides. All right, and if we do that, these will cross out. We get a w equals, we can subtract these, and we get a 66. Positive 66. That is our solution. We're done. It's as simple as that. Now we could go back and check, plug in that 66 for the w, plus 32 equals 98. And if we take the 66 plus the 32, we add those up. Lo and behold, we do get 98, and 98 does in fact equal 98. Therefore, we have a true solution. All right? Excellent. We're going to do one more fraction problem here. And this one I want you to try it first on a separate sheet of paper, and then we'll do it together and see how you did. So the problem will be x plus 1/4 equals negative 3/8. I'm pulling this one right out from your book. So go ahead, pause the video, give that one a whirl, and then we'll do it together. All right, so hopefully that didn't go too badly. Let's give it a shot here. So what do we want to do? We want to get x by itself, right? And to do so, we are going to get rid of this positive 1/4. And we're going to do that by subtracting the 1/4. But if we do it to this side, we must do it to this side. Okay? So these will cross out. We get our x. And again, well, this one is kind of set up. They're already, they're not mixed numbers. So let's just go ahead and find our common denominator over here. So the common denominator between an 8 and a 4 is going to be an 8, right? And then a 4 times 2 is 8. So 1 times 2 is 2. 8 times 1 is 8. 3 times 1 is 3. Nothing changes. And they're both negative. So adding those up, we have a negative 3 and a negative 2, which is a negative 5 over 8, right? So we have a x is equal to a negative 5/8. All right. Excellent. Very good. It's about as simple as that. So right now we're just focusing on addition and the rule that states that you can add anything you want to both sides of an equation and still end up with the same solution, end up with an equivalent equation. All right, so we will stop there today and go ahead and work on your homework for today or your seat work for today, and we will continue this in the next lesson.